I think we can start. Hello, everyone. My name is Sławomir Kosowski, and today I'd like to present and say a couple of words about testing iOS applications. Already not working. Nice. Now it's working. Perfect. OK, about me, currently I'm working as web and mobile application testers. 90% of my time I'm doing mobile, and 90% of mobile time I'm doing iOS, hence my presentation. Previously, I've been working on a couple security projects. I was mainly building different identity access management systems. I was working also as a system administrator. And I'm working in offensive security testing applications. OK, so I'd like to know better the audience that we have here. We are not so many, but do we have any iOS developers? Hands up. Oh, one, good. Do you develop in Swift as well, or Objective-C only? Objective-C, cool. Do we have any Pentesters? And I have that we have. OK, quite a few. Perfect, perfect, guys. Any people related with Android? Developers, testers? Cool, cool, great. OK, so a couple of words about what we will cover and what we won't cover. The presentation is about application testing, so we'll give a brief introduction to iOS itself, and then go through Objective-C runtime. We'll set up a testing environment, and we'll go through very basic and simple lifecycle of a pen test on giving some real-life examples. Things that you won't see here is low-level stuff, mainly jailbreak development. We also won't cover Swift, as it's quite new, and there are still many changes. I think that the new version is coming. We also will focus on black box assessments, and I think it's the most frequent case where we do pen test of an application and we don't have access to source code. And also, I won't cover things like classical web app testing, which I assume that the audience knows here. OK, so about iOS itself, it's a mobile operating system from Apple. It's Unix-like with XNU kernel. In general, it's closed source with some exceptions. You can see, well, you will see a link. Open source Apple.com. There are a couple of libraries that you can look into. And the applications are written mainly in Objective-C and very recently in Swift, as Apple introduced a new language. And Cocoa Touch is the main API handling all the touch events from the user and all the user input to the system. Just a couple of words about the security model. What you have to understand is that iOS is basically the entire ecosystem. Starting from hardware to software, Apple controls vast majority of the hardware, from CPU, bootloader, TPM, up to the software with its own operating system and applications. And unfortunately, we won't have time to go into details of those things. Just a couple of words. First of all, those are security features of the operating system itself. Secure boot chain, meaning that in the CPU itself, in the silicon, there is Apple CA certificate, and all the code that is being run and that's being loaded by the system, by the device, is being checked if it has known and good signature. Secure Enclave is basically a TPM for mobile devices. It's included in all devices that after iPhone 5S, I believe. Encryption and data protection. Starting from iOS 8, all data on device is encrypted. Even though if you don't have passcode, the data is encrypted. Obviously, it protects only against offline attacks, but all data is encrypted, and in iDevices there are no SD cards, so we don't have problem here. Trusted code execution is a bit related to secure boot chain, meaning that only Apple-signed code can run on devices, and also all third-party applications have to be signed by Apple. It's a bit of the shortcut thinking because there are some exceptions, but in general we can assume so. And network security, also worth mentioning, is that starting from iOS 9, only TLS connection are allowed. If you want to connect to a resource over HTTP, it must be whitelisted. So Okay, and Keychain. What is Keychain? Keychain is also a security feature. It's basically a SQLite database which stores all sensitive information like passwords, tokens. Applications can access the items in Keychain. They can read the items in the keychain only for the same keychain access group. So two applications can share items, but they must belong to the same access group. And worth mentioning, obviously, keychain can be read on the jailbroken device, so it can be fully dumped with ready-made tools. Application Sandbox. So it's compared to Android. Here it looks a bit different. So we have only two users on the system. You have a mobile and root user. And all third-party applications, they run as a mobile user. They are in Sandbox, which means that they can access only their own data. They can't share explicitly data with other applications. And also, compared to Android, where the IPC model is very broad, here IPCs are very, very limited. Again, we don't have time to discuss them, but in short, IPCs are only via URL handlers and pasteboard. Good. Now, Objective-C. A couple of words about Objective-C. It's an objective language it's basically a superset of C, which means that you can use Objective-C compiler to compile C applications, and you can embed it, C code in your applications as well. It has a couple of interesting features, and we'll see a couple of details on example. So one of the features is it uses infix notation. So you can see that, first of all, you use square brackets. And when you want to call a method on a particular object, you have object, then method, and then after a colon, you have arguments. So if you want to initialize an instance of an string class with string confidence 2016, you pass actually a method string with a parameter. This is actually a string with @sign. Simple as that. In Objective-C, you have two methods. You have class and instance methods. And they are denoted. This is the interface of the class. And you have two types of methods. One which is a class method, and you can see the plus sign here. And one which is an instance method, and you can see the minus. And the difference is simple. You can call the class method on its own, whereas in order to call an instance method, you first have initialize an object, actually allocate memory, initialize, and then you can call instance method on a particular instance of an object. This will be useful later on during our application analysis. Okay, so it's interesting what happens under the hood in Objective-C, because you don't actually call a method in Objective-C. You actually pass a message to a method. And what happens under the hood? So in Objective-C runtime, you have a function called Objective-C message send. And here is an example from Jonathan Zdziarski's book. When you basically do something like this with Objective-C, so you have say something method on say something object, you allocate, initialize, you actually pass a method say with a parameter hello world, and then you release the object. Now, what happens under the hood is actually it gets translated into pure C calls, and you can here see a nested chain of Objective-C message send functions. And finally, ending up on the Objective-C get class, say something, okay? And then we have something called NSSelector from string. So basically, Objective-C message send takes two parameters. First is a pointer to an instance of an object on which we want to pass a method, and second is selector. Selector is basically a C string with a name of a method registered in a runtime. So then you might think how the call graph looks like, and it looks like this. So those are basically, this is almost the same function, Objective-C message sent with small variation, class from which inherited, returning structure, and normal function. So we don't have much information from what's going on in the application just based on the call graph, but it will be very useful to see what happens when this Objective-C message send function is called. And due to this property of the language that it heavily uses this Objective-C message send function, the implementation of the method is resolved dynamically, which means that we can change in method implementation during the runtime. And this feature is called method swizzling, and it's actually not a bug, it's a feature, and we'll heavily use it in testing, and I'll show you how. I also included some links I highly recommend because the runtime itself is very interesting. It's written in C and assembly. It obviously must be very efficient, and I recommend digging into it more. OK, so with very, very quick introduction to the system and to the programming language that's used, we'll go to the actual meat of this presentation, so application analysis. OK, so first of all, what tools you would need. So for static binary analysis, classical, IDA Pro is very useful. However, Hopper is also nice. You can get quite far with Hopper. It's disassembler and decompiler, which is very interesting, and the price is incomparable. I mean, Hopper costs something like $100 or €8, I think, where IDA Pro is itself is, I think, $1,500 plus hex rays for decompiler. And also, when you buy hex rays, you have to buy separately for 32 and 64 bits. And Hopper has all of this in one license. ClassDump is a tool that will allow us to see what methods are in a binary, what methods are used, and how interface files look like directly from the binary. Auto will give us some information about the binary itself, and strings all from Unix systems. OK, again, in iOS, compared to Android, we heavily rely on runtime manipulation, which means that we do some static analysis, but mainly we interact directly with the application. And we'll see how in a minute. What tools we would need. There are two widely used tools. One is Cycrypt. It basically injects into the running process, into the running application, and it gives you an interactive console, and you can interact with the application from the console. You can you can actually pass messages to methods with this command line. Frida does something similar, however, in a completely different way. The main difference for us is that Frida can inject with a hook into a starting process. So let's say that the application is doing jailbreak detection and it closes immediately. You don't have time to hook into process with Cycrypt. You can do it with Frida. Very useful, very nice tool. Documentation is a bit lacking. Debugger, obviously, debugger is very important. So some time ago, Apple moved from GCC to LLVM, and subsequently from GDB to LLDB as a debugger. And GDB is fully supported until iOS 7. For those people who are not into iOS, now we have current version is, I think, 9.3 point something. So we have already two major releases that are without GDB. And from iOS 8, we have LLDB as a default debugger, which is working. However, some features are still missing in LLDB, and it's not, well, it's fully functional, but some useful stuff is missing for us. OK, so you want to test the application, what you actually need. Unfortunately, no simulator, as in case of Android, so you have to have real device to do meaningful testing. I recommend getting a bit older, maybe device with a bit older iOS, because you have still a bit more tools than for newer iOSs. But make sure that the iOS that you are using has available jailbreak, so that you can actually jailbreak it, because testing without jailbreak doesn't quite make sense. If you want to test any legacy applications, you need another pair of devices. My recommendation is to use 2 devices per iOS version, jailbroken and non-jailbroken, because it happens that developers are giving you the application to be tested. You launch it on jailbroken device, and it doesn't launch. You think, well, it might be some tricky jailbreak detection function. What's happening? So you start debugging. But when you check it on non-jailbroken device, you see that the application is actually not working. So yeah, and it can save you some time. OS X and Xcode is very useful. You don't have to have Mac to test iOS, but it's useful to compile your own code and check also maybe do some proof of concept attacks. Okay, if you basically jailbreaking device requires exploiting it. You have ready-made jailbreaks for some iOS versions, but obviously not for all iOS versions, because as soon as jailbreak is released, Apple patches the vulnerabilities. And if you fail to jailbreak the device, you can restore it with iTunes, but it will also upgrade to the newest version. You can't restore to the previous version, which is obviously a problem, because then you can't jailbreak it. There is a handy tool called semi-restore, which you can use, and it happened to me that jailbreak failed in the middle, and then I couldn't launch Cydia application, and then this tool is handy and saved me one iPad. And again, no possibility to downgrade iOS version. So again, if you also buy a device, also especially used one, make sure that it has iOS with currently available jailbreak. Okay, jailbreaking as such, if there are already jailbreaks released, it's very straightforward. Usually you just click next, 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 done. It reboots a couple of times, and then it's basically all. What jailbreaking does, first of all, it doesn't break the application sandbox. It allows to run unsigned code, third-party code, and it also gives you shell access to the device, because normally there is no terminal or such thing on iOS. And also, it will install the Cydia application store, from which you'll get other useful stuff like OpenSSH or Aptitude. And this is how it looks like. This is a screenshot from the Cydia application. First thing you do is you install Aptitude and you install OpenSSH. You have those two users by default on iOS. You have root and mobile, and default password to SSH is Alpine. And I listed some tools that I usually install directly on jailbroken device that then are useful for testing. Okay, Frida, I won't spend time on this. Very straightforward. You go to the website. You install one part on your workstation and the second part on your iOS device, an agent. Very straightforward, nothing fancy there. Now, we have tools. We're now focusing on the application. On Android, as some of you know, the applications are packaged in APK files. In iOS, this is IPA file. IPA is simply a zip archive. You just rename it or you unzip it, and you have all the bundle. You have application binary and all the static data that is required for applications, so graphics, certificates, any other code. iOS uses Mac-O binary format. And usually binaries contain, when you see a binary, usually it contains two, let's say, sub-binaries, and this is called fat binary for different architectures. So the device can choose the proper binary for its CPU. Okay, and now we have our device jailbroken. We have installed our tools from the list that I shown, and now we have a tool called install IPA. When you use -L, it lists you all the third-party applications. You use -I on the application, this QR code reader, and you can see that here it gives you 3 folders, and the applications are installed into the unique folders with bundle ID, so it's a convenient way to check where the application was actually installed. Okay. So how will it test? Well, the usual test approach is like this. First, you get the IPA file from developers, from client, from the store as well, from the Apple App Store, depending on you. Then the application may actually prevent you running on jailbroken device, because, well, jailbreak may pose some risk for the end user if he doesn't know what it really means and what it really does. So some, especially financial applications, they prevent running on jailbroken device. So you have to bypass it, because you have to actually analyze the application. It's not really vulnerability itself. If you can bypass jailbreak detection, it's not a vulnerability, but you need it for testing, right? Then the application is, if it's not standalone application, then it will probably contact with a backend server, and it usually does it over HTTPS. Good. And the application may actually use certificate pinning. Certificate pinning is actually prevention against the rogue CA, and the application has the server certificate bundled into it and checks if it is correct. So even if you install your Burp profile on the device, still the application won't trust it. So again, you have to bypass this. Then you inspect the traffic use, you do usual web stuff. There's nothing really fancy there. Then, my opinion, most interesting part is this one, abuse application logic by runtime manipulation. You can also do memory forensics. The attack vectors are now very limited, and some other minor things, checking local storage, client-side bugs, and other minor checks. OK. Now, the binary encryption. So actually, Apple, and this applies only to the binaries that you download from Apple App Store. Because Apple App Store, they use the third-party DRM, which means that the binaries are encrypted. Now, obviously, if they run on device, they must be somehow decrypted, so you can get them. But if you download the IPA from App Store, you put the binary into Hopper, IDA Pro, whatever, you'll get garbage because it's encrypted. Now, there are some tools that do it for you. You just put the name of the tool, which is called Clutch, the binary, and it decrypts it. Alternatively, you can use debugger. I recommend doing on your own. I won't go into details because it's broadly documented on the internet. No point in repeating it here. OK, so we have unencrypted binary. Now we can start analyzing it. The binaries on iOS have three security features set by the compiler and during compiling time. Automatic reference counting. It counts the number of allocations and deallocations of objects to prevent memory corruptions. Stack canary to prevent buffer overflows. And PI, which is position-independent executable. And this is full ASLR for the binary. You can check those features. By the way, this is how you do. Unzip IPA file. Dumb vulnerable iOS application will use it here. You can download it from the internet, and you can train your skills on it, basically. You go to the directory, and then use this O tool. And it gives you, actually, this is this FAT binary. So you can see that you have one output for architecture ARM v7, one CPU, and second one for ARM 64. And here is the flag Pi, so all is good. We have Pi enabled, fine. You do similar with O2 with stack. You can see you have 32-bit addresses, 64-bit addresses with flag set up. Everything is good. Nothing really complicated. Similarly with automatic reference counting. I just snipped it for brevity. Good. We have our binary features checked. So now we can set up the environment. Again, nothing really fancy. You launch Burp. In the settings Wi-Fi, you go to the Wi-Fi settings, you put your Burp. One remark on Burp, just remember to listen on all interfaces because you listen on the Wi-Fi. Obviously, two devices are on the same Wi-Fi network. Now, we have everything set up. We want to launch the application, and it happens that the application doesn't want to launch because there is a jailbreak detection. Before we can bypass this, let's talk about how it's being detected. Usually, the checks are really trivial. So first of all, it checks for existence of additional files that are installed during jailbreaking, which is like bash. It also can check for API calls. Forking is forbidden on non-jailbroken devices. System null normally would yield you the currently available shell. And also, Cydia URL handler, it is this third-party app store. It checks if the URL scheme is registered. I also included an article for reference if you want to read more. OK, now we want to bypass it. How we can do it? Obviously, lazy people, they invented a tool for it to make it automatic. And this is called XCon. You can download it from Cydia. But it doesn't work always. And then you need to do it manually. And I usually do using one of those tools, which we already discussed. And now we'll see how we can get it, how we can do it in practice on the example of this dumb vulnerable iOS application. First of all, what we have to do, we use the lipo is the command to only make a thin binary from the fat binary. So we want to extract only one architecture. And then we use class dump tool, and it's snipped. And we usually check for strings like jailbreak, detection, root, check, things like this. And developers are pretty good on giving us hints on where to look at. So we can see that it has two class methods. App is cracked, device is jailbroken. They return Boolean. Perfect. We launched our binary in Hopper. On the left-hand side of the Hopper, you will have the search pane. and you start typing jailbreak, right? So you can see that it turns out that there are two classes, SF anti-piracy, jailbreak detection VC. You can also decompile the class. It also gives you the return type. So we can see that there are a couple of methods used there. OK, good. So we know now that probably some of those methods are used to detect the jailbreak. I still have some time. Good. So in this application, you have basically two buttons, one for jailbreak test 1, jailbreak test 2. They employ two different methods. So we'll try to bypass this. When you click, it obviously says that the device is jailbroken. We want to bypass this. So we launch the script, -p, and this is the process ID. And remember that this SF anti-piracy is jailbroken. This is class method. We can call it on its own, right? So we do it here, and it returns true. Device is jailbroken, right? Now we want to call the second method, that is jailbreak detection VC is jailbroken, right? So this is this one. And we can see this minus, so this is an instance method. And now in script, you have a function called choose. And choose will go through the heap, and it will look for signature of this particular class. And it will return you an array of instances of this class. So you put choose, and there is empty array, no instances. And actually, this is because we haven't tapped the second button yet, the second test. After we did it, we do another choose. The object was created. We have the address. And then we can call it is jailbroken. So this is the main difference between instance method and class method. In instance method, you need to have a particular instance already created in the memory. Good. Now we want to bypass this, right? So we see that probably if this returns true or false, so it's pretty trivial to patch it and to return in those cases false, and the device won't be jailbroken. Indeed, you can do it very simply with script. You just use prototype is jailbroken, and you replace the implementation of the function. This is actually pure JavaScript. So you just put function return false. You call a method. This returns false, and device is not jailbroken. This is a very trivial example, but you'll see that in real life, developers, they don't do much more than this very often. OK, second tool, and to be honest, Frida is my favorite tool, and I'm a big fan of dynamic instrumentation. Frida basically requires you two things. First thing is you install it on your workstation. Second thing, you install it on your iDevice. It uses USB connection, not Wi-Fi. And we'll use a tool called Frida Trace. And what Frida Trace does is basically you launch an application, and you pass an argument, the name of the method that you want to trace. This is jailbreak detection VC is jailbroken. And this will create a file with callback functions on enter, on leave. Again, this is plain JavaScript. And this will enable you to see what arguments were passed to the function and what values were returned from it. So we'll basically replace return value and change it to 0, redval.replace 0. And we'll see what happens. We launch the application. This you do on your workstation. And it says you're instrumenting functions, all good. Started tracing one function. It detected it, all good. And then you also see time. We clicked on the button, test jailbreak, and it was somewhere after 7 seconds after launching the application. And it logged as on the output, originally returns 0, 1, changing the return value to 0, 0. And indeed, it worked to bypass the jailbreak detection. And you also can see that it was clicked for the second time. Obviously, it also worked. This tool is also extremely good if you want to trace what's happening in the application. Sometimes you have applications that use obfuscation, that try to scramble things, encrypt things. And this is very, very useful when you trace the methods, not necessarily for jailbreak detection, but to see what happens in the application. And you can do really some cool stuff if you're lucky to get an application that does things like this. Good, so we bypass the jailbreak detection, which, by the way, is not vulnerability itself. At least I don't think that it is. It's just like root detection on Android, but still you have to do it to test meaningfully. Then you test for certificate pinning. And there is also a tool called SSL kill switch, which tries to automatically disable certificate pinning. And first thing you do is you make sure that this tool is not enabled and you don't have your Burp profile installed on the device. If it's not installed and you can see the traffic in Burp, it means that the application doesn't do certificate validation at all. So basically, like if there wasn't HTTPS. Then you install the Burp profile, and if you can see the traffic, then it means that there is no pinning. So it's less serious, but still. Then if you enable, for instance, SSL kill switch, and you can see the traffic from there on, it means that the certificate was pinning and all is good. However, if you still don't see the traffic, it means that you have a problem and you have to bypass it. And again, this is not a vulnerability, but you need to be able to inject into the traffic to test for bugs, like in the web applications. Then you have to do it manually. And there's a very good reference in iOS application security book on the implementation with iOS API. You basically also look for strings in the binary like X509 or CERT. You also look for API calls and then try to see it on your own. Recently, also developers started to use OpenSSL directly. And using OpenSSL has one more advantage, that you have to tunnel your traffic on your own, because OpenSSL ignores your proxy settings in the device. Right, now more tedious part and a bit less interesting, but still you can have some good findings there. You're checking for local storage. Applications heavily use SQLite database to store the data, and you can often find there some confidential information, personal details, financial information, so it's very good to look into it. You have also something called plist, it's property lists. It's Apple format for binary XML files. You have a tool to look into them, and there are also sometimes interesting things stored. Application screenshots, web view caching, those are all minor and more tedious things, pretty straightforward. My favorite approach personally is this forensic one. And basically what you do is you do ls on root directory with full time. Then you play with the application, change a bit, interact with it, and then you do it once again and you do diff on both. And you see and you look what has changed. Like this, you can see if there was any data written to the local storage, if there was any data written to the keychain, things like that. Also, one hint: databases use something called write-ahead log, which contains uncommitted transactions, which means that something might not have been yet committed to the database itself, but it's been written to write-ahead log, and there might be also some useful stuff. Okay, two tools that I'll very briefly mention is, one is iExplorer. You can use it on non-jailbroken devices as well, now with some limitations. You can look into the content of your iDevice. By the way, it's valid until, I think, iOS 8.2. But you can also look into backups, iTunes backups, because when you plug the USB cable to the iDevice and to your PC, then it automatically backups whole data in iTunes. Second tool, it's still working. I checked it on iOS 8 point something. I don't recall now which one. It's kind of like Frida. You install an agent on device, you trace an application, and then on your workstation you have nice web interface with traces to some functions. It's not obviously as flexible, but it has a nice GUI, and you can still see a lot of things going in the application here. Okay, and some closing thoughts from my side is that still server-side bugs are most impactful, because the platform as such is maturing. It uses encryption, it uses TPM, so there are less and less scenarios for getting the data from the device itself. I'm not saying that it's impossible, but it's getting harder. The issue might be, for instance, when users choose weak passcodes like 1234, 4 zeros, and it obviously happens. And good practice is also to wipe device after 10 attempts. Then you are even less lucky. And the interesting stuff that I got from Apple App Store, it's from March 7 this year, and this is partitioning of iOS on all iDevices. And if you have the image in your head how it looks like on Android, this is actually ranging from Android 2 point something to Android 6. And this is one of the, well, advantages and disadvantages of the platform of unification, but you can see that the security is much more controllable in this scenario. Right, from my perspective, I started with web application testing, and really, well, after some time, you're probably getting bored if you don't touch new technologies, but if you're testing only legacy old applications. So mobile stuff is fun, definitely. The platform itself is, again, solid, but developers obviously will do implementation errors, design errors. They will try to implement homegrown crypto, and this will remain. From my perspective, moving into mobile is good in a sense that if you want to get closer to native security, to reverse engineering, you'll start touching things like this. You'll start reading API documentation, you'll start reading assembly, you'll start using disassembler. It's stuff that you really want to use during web app tests. And also, they give you a chance to, Apple give you a chance to constantly learn because they introduce new technologies. Now, things like Apple Pay or Health Kit, it needs you to be on your toes all the time. Also, yearly release of new iOS, and they release new iOS, and it happens that half of your tools that you wrote, they are not working anymore. So you have to rewrite or maybe, rescript your tools. Also, from my notice is that there are a lot of tools for iOS smaller than 8, but for recent iOS, many tools, they don't work. And this is why I try to rely on stuff which is as simple as possible, like debugger, like Frida, which is basically an engine, very, very rough engine. And in this way, you are pretty much sure that you will be able to test the next generation of devices. Obviously, unless there are jailbreaks developed in the same pace as new iOSs, because otherwise, we don't have job. Yeah, and so I think I said everything. This homemade crypto, security by obscurity. Developers often assume that, well, no one can change the request made to the server, so it must be trusted, right? And you find SQL injection, you find privilege escalation, stuff like this. Right, so that's all from my side, and questions from the audience.
Please wait.
How do you see the future with Apple improving the protection from jailbreaks, implementing Touch ID? How the testing will look in future?
Well, I believe, and history shows, even with release of iOS 9 and rootless system, jailbreakers prove that they can still do their job pretty good, and they're still developing jailbreaks. It's getting harder and harder. You can also see it in bug bounty programs like ZeroDoom, how much they pay for a full jailbreak on recent iOSs. But also, introducing new technologies introduce larger surface for attacks and possibly more holes. On the other hand, there were like many discussions that jailbreak developers, they just burn exploit too fast. They just release the exploit, they release the jailbreak tool, Apple immediately patches it, and they release a couple of really neat and very good exploits that could be used for a bit later to keep the jailbreak time for jailbreaking the newest version longer. But I believe that for nearest future, the jailbreaks will be developed. Questions? Who else? I expect a good one.
Hello, very interesting talk. I have a question about the jailbreaking detection. Do you think we can automate it? So maybe we can imagine someone making a malware that hide as a bank application that try to avoid the jail detector, and then the user is dumped, he install it, and then you get his account.
Again, the scenario of installing the application on end-user device is kind of limited, as it's opposed to Android. You have only the official App Store. You have two other methods of deploying the applications. One is ad hoc, with ad hoc certificate, but you have to plug it into your Xcode, plug it with the USB cable, and deploy it. So you just can't send a file to someone, hey, install this file, like with APKs, right? This is all the malware on Android. This is where it comes from. And on iOS, it just basically goes through the vetting process, which is, by the way, not perfect. Now, the second, more viable attack scenario is stolen MDM profiles. Companies use MDM to push applications. And then if you are able to hack delivery server, then you are able to steal certificate and push the applications. And then this is viable, but you can already install malware. Yeah. Obviously, jailbreak detection can go very far, and they can try to, developers, can try to obfuscate the code. They can also provide anti-debugging techniques, things like this. So, but from my experience, they never did it. It's always simple. And it's like with root detection. I, as a user, I should be warned about the implications, and then it's my choice if I run the app or not. Question again.
But there is one more risk involved, the exploitation of application already installed. For instance, the web browser. If you find a remote code execution in the web browser on iOS, you can run a code that will jailbreak the system.
Not exactly. For jailbreaking, you have to have multiple exploits. First of all, as applications are in Sandbox, okay, if you get code execution, then you are still in Sandbox, then you have escape from Sandbox, okay, but you are still in user land. So you need to have a kernel exploit. Then you go into kernel, so then you have to patch the boot ROM. But boot ROM is actually signed, so you have to find the hole there. And also booting process is like multi-step process. I have some additional slides. So this is how booting process looks like. You have this root CA lie down in Silicon. Then you have LLB, you have iBoot, you have iOS kernel, and OS itself. And what jailbreakers they do, they usually exploit this or that. This will probably give you theatered jailbreak, which means that you have to have your iDevice plugged to the PC. And once you reboot it, you lose the jailbreak. And this is what we call jailbreak normally here, like untheatered, which means that you reboot your device and it's constantly jailbroken. So in short words, it's not one exploit. It's not as simple as that. And this is also why the prices for exploit are that high. Even reading the write-ups, I must admit, I tried to read the write-ups for this, and if you are not very into the platform, it's extremely hard to understand what they're doing.
Thanks.
Question on the back.
Hi. I've got a question from a bit different perspective, because you said you believe that the platform itself is pretty solid. I'm not actually much into Apple, but I think we've all heard about rumors about backdoors that Apple leaves intentionally. So could you share some thoughts, experience on that topic?
I'm not Apple advertiser. I'm running Android, by the way. It's. I think if you have other problems, if your enemy is NSA or another security agency, you are in much bigger trouble. Everyone is now peeking into your privacy. That's true. If you are afraid of backdoors, well, might be, but do you have any specific backdoor in mind that was detected? Yeah, no.
Please wait.
Yeah, I think that everything is possible. It's only software and hardware, right? So it can't be.
No, so my point was if you've actually come across anything like that, or is there anything real substantial you could find in the internet?
Well, media says that Apple is being pushed to really, install backdoors. It was pushed in the past, and there are these big discussions. And their PR says, my impression is that they refuse to do so. If they haven't done this, if they have done this or not, I don't know. But again, like big platform, hardware plus software, it gives you unified attack surface. You own one, you own all of them, right? On the other hand, you can control security much better. So it's always a trade-off.